Hello everyone, I hope you guys are doing well. So, this is my topic about the modern e commerce and application. This topic is basically related to the web applications that we used in our day to day life. So, this project is going to help the web e commerce uh, sites, and usually it is used for designing scalable event driven and composable retail system for enterprises scale. This is basically a overview of my main topic. The subtopics which comes under the architectural paradigms, it is, you can see the part 1, where we have to use the transitioning from monolithic platforms to composable commerce. Monolithic versus microservices. So here we bifurcated those paradigms into two types, which called monolith and microservices. The first one is basically brings out the legacy monolithic systems, which is basically a UI presentation and backend logic, where we use both front end as well as backend for creating the monolithic system, which is a whole application, vasting service resources, high blast radius, which is when there is a failure in one module brings down store. Now the second one is about modern microservices pattern. The domain service is basically a communicating via APIs, then independent deployment pipelines per service team, targeted elastic auto scaling during traffic spikes, and fault isolated architecture for continuous availability. Here we are going to see the microservices patterns which are used in day to day life. So this is all about the monolithic and microservices. Going forward, we have the MAC paradigm. So here we are looking for the bifurcations of paradigms. The MAC paradigm is like composable commerce standard. Here we can see the diagram related to the this paradigms, and this clearly shows the infrastructure of cloud components, where we have compute, storage, software, services, and networking. So, as you can see, compute is basically related to processing tasks by using virtual machines, and serviceless functions. Storage is again a different type of data management in web e-commerce. Software is basically related to the tools that we use in infrastructures and applications. Then going ahead with the services, we have physical as well as virtual servers as written over here for the host applications and services. Networks are common connectivity for the communication in web e-commerce. So these are all five cloud infrastructure components, and here we are going to see basically a composable commerce standard. So MAC basically stands for microservice API first cloud native SaaS and headless architecture. It is best of breed solution for search, which checks out the inventory rather than relying on a single rigid vector stack. So MAC paradigm is used for the APIs. Going ahead, we have core architecture layer. Core architectural layer is related with the presentation, API gateways, and domain services. So these three are the core of architecture layers. Presentation brings out the POS, GraphicQL APIs, consuming APIs, and REST APIs, which is related to the mobile apps. Then API gateways used for JWT auth, rate limiting, and central Ignis handling, SSL termination, uh, and for the protocol translation in ways of like networking. Then domain services are related to the domains and the services which are provided by the domains, which come as like order fulfillment, payments, checkouts. So it deals with the outer material of web e-commerce. So these are three core architectures of these paradigms. Then headless commerce front end. Headless commerce front end is basically, here we are going with the to deal with the front end area of the web apps. So web apps usually deals with the UIs, their logic, then omni channels, age performance, marketing, eligibility. So these are all the fundamentals related to the front end of e-commerce, web e-commerce. Then peak traffic performance. So here you can see the graph which is related to the average API response latency under the 10, and which again a product with the flash scale concurrent user specs. So here three graph as you can see is given. The monolith platform is shown in red, whereas the microservices of K8s shown in blue, which is about 32 ms, and serviceless edge Mac is shown in green, which is near about 85 ms. That means the performance of Mac is moreover better than the monolith and microservices, and where you can see the serviceless edge is also available. So this is basically a comparison graph between the monolith, microservices and Mac. Now event driven reliability, platform availability. Event driven reliability is related to the reliability of the web services or the web apps which we use for the paradigms. Now asynchronization realization resilience is about for leveraging messages brokers like backend services communication by asynchronization order created payments all are captured. So this is for the payment material for incoming orders remain qualified and their transactions remain fulfilled. So it is near about 99.99%, that is 0.1% to complete 100%. Modern checkout lifecycle, we have ingress request, inventory log, payment intent. So as you can see, we have ingress request is to check out the life cycle of this web services. We are going to have this four events basically. First one is ingress request. The request will be ingressed for the routes for payload. Then inventory log, it distributes all the stocks item temporarily. Then payment intent, payment is asynchronously, that funds would be insynchronized and authorized by the payment gateways. Event fan out is event program for the order centered, and its notification is given on the web services or a website. Now microservices domain breakdown, it is breakdown into domain services, core responsibility, primary database and scaling trigger. So these four are microservices domain breaker. So microservices deals with this four responsibilities or four main core functions which we can say, which deals with the product catalog, inventory services, order management and payment gateway. So these four are the major blocks for the like microservices breakdown. Here we can see like core responsibilities about in product catalog SQs are used, then inventory service, real-time stock tracking and reservations, order way management, order processing workflow and payment gateways about tokenizations and interactions and fraud check. While going ahead with the cloud infrastructure allocation, so allocation is required for any website to infront and make the manufactured essentials accordance with the cloud. Here we can see there is a bifurcation by using different colors. The computer and Kubernetes are shown about 40% in blue color. Database caching is about 25% in a green. HCDN and WAF is about 20% in orange, and event quiz and buses is about 15. It isn't given in purple. So the max use of compute and Kubernetes are shown by this pie chart, and that means the cloud infrastructure allocation is more in computes and Kubernetes. So these are about the cloud related resources expenditures, and it's about scalable memories. Now here, if you have any question, please comment down below. I'll sure to give answers of each and every questions of you. I hope you all have understood the content. Thank you.